Hello Year 11 and welcome to our second video here for our second topic. We're looking at terminating and recurring decimals. Terminating decimals are those with a finite number of decimal places, such as in example 3 here, 3.552. To express that as fraction, I take the number 3.552, and thinking of some of the operations we do with fractions sometimes, I can multiply the top and the bottom by the same number, and of course that doesn't change the value of it. So I'm going to multiply the top and bottom by 1,000 here. So that's going to be 3,552 over 1,000. If I simplify that down, I'm going to use my calculator. 3,552 over 1,000, and I get 444 on 125. 125. Now you could break these down to the prime factorizations, find the highest common factor of those two numbers and remove it. But the calculator does the trick pretty well. It's important though to recognise these ideas in case you need to apply them algebraically at some stage, right, where the calculator is not going to be so much help. Note that my answer there is an improper fraction. It has the numerator is greater than the denominator. Writing it as a mixed number, that's 1 and 2 and whatever over 125. Just a bit confusing once we introduce other things, whether it looks like it's being multiplied or... So improper fractions are perfectly acceptable. They do need to be simplified so that they have no common factors in the numerator and denominator. Those things aside, recurring decimals here, where we have a regularly repeating pattern of digits. These can be expressed as a fraction. There is a neat trick for doing so. And we're going to have a look at here. 0.4 recurring, I'm going to start by saying let x equals 0.4 recurring. And because I have one digit that recurs, I'm going to multiply x by 10 to the power of 1. So 10x equals 4.4 recurring. Therefore 9x, this is 10x minus x, is 4 point, all these 4s, minus 0 point, all these 4s, and those parts sort of cancel each other out, and I get 4 minus 0 equals 4. And then divide through out by 9, and x equals 4 over 9. Can't be simplified, that's my answer. Right, 4 over 9 is the same as 0.4 recurring. In the second example here, I have 3 digits that recur, the 8, the 2, and 3. So if x equals 1.4823, then I'm going to multiply by 1,000. Okay, because I have 3 digits that recur. Oops, I've got those things there. So I'm going to multiply by 10 to the power of 3. Okay, this is going to be 1,482.383. Now, I could have left that 3 off the end, put the dot above the 3 here and the 2 there. However, I wanted to line those up carefully there so we can see that 999x equals this minus this, and the 823 recurring part cancels out with 823 recurring part, and I've got 1,482.3. Let's pull out the calculator. 1,482.3, okay, minus 1.4 equals, and I get 1,480.9. That means that x equals 1,480.9 over 999. That's a bit unsatisfactory, you know, because I have a decimal up the top. So I multiply top and bottom by 10, and I get 14,809 over 9,990. Can it be simplified? This way, I think, is look at the calculator there, times 10. Okay, got that, and I'm going to put that over, oh, that didn't work, 14809, 9, over 9990 equals, there we go. Well, it didn't simplify down. It gave us our answer doesn't like doing that. Oh. Answer here. Sorry, I've made a bit of a mess of this. But we used the calculator to confirm that I can't simplify that fraction down any further. So there we go. 14,809 over 9,990 is equal to 1.4 recurring 823, 823, 823. And so on. Righto, that is recurring decimals. Practice those. It's not very tricky, but if you forget how to do it, you're going to be sharp to remember how to do it, like to work it out from scratch if you try to do that in a test. One more little thing to do here. Oops, not that. This unitary method for working with percentages. Again, not overly taxing, just got to have an idea of what you're going to do. This example, 47% of students are using a blue pen, and that 47% represents 799 students. So how many students are there altogether? 47% is equal to 799. What's 100%? Well, we can think that 799 over 47. It's going to tell me what 1% is. 47%, 799, therefore 1% is 1/47th of that. So 799 over 47 is going to tell us 1%. If I multiply that by 100, it's going to give me the total there, 799, I'm thinking it's fraction, over 47. Over we go, times 100. What do we get? It's 1,700. That's it. Done. Unitary method. I call that because we find the size of 1 unit, of 1% of that. Okay. Find 1%, then we can find 100%. Okay, that's recurring decimals and a little bit there with percentages. Terminating and recurring decimals. Any questions, please jot them down and ask me in class. I'll see you there.